Yes guys, so we are doing question number 6, last one. Now it says that 3 urns contain 6 red, 4 black balls. First one and second contains 4 red and 6 black, and third urn contains 5 red and 5 black balls respectively. 5 black balls respectively. Here the balls here, black balls. Here it is, black balls respectively. Then it says one of the urns is selected. One of the urns first is selected. Urn. One of the urns is selected at random, and a ball is drawn from it. If the ball is red, ball drawn is red. Okay. Then find what is the probability. Then find the probability. We have to find out here. Then find the probability that the ball drawn is that it is drawn from the first urn. Okay, this is drawn from the first one. So solution, let me find out. Now here let us take that event E1, E2, E3 is the selection of the balls. Let event E, okay, that E1 is the event, the urn 1 is selected, the first urn is selected, the first urn is selected, okay, and E2 is the second urn is selected. The second urn is selected. Let me take the other events here. Anything we can take. U1, U2. Let me take U1. This is U1. This is U2. U2 second urn is selected. Okay, this is U2 here, and U3 the event. U2 be the event, the event that third urn is selected. Third urn is selected. This is your U3 event. So what is the probability of this selection? Therefore, and A, let me take any event A, and A be the event, and A be the event, let me take that ball selected is red. E, let A be the event, that ball is red, or red ball is selected. Ball selected is red. Ball selected is red. Okay, that is the point. Now let me solve it here. Solution. See here. What is the point? What is the prior probability? So the prior probabilities. What are the prior probabilities here? What are the prior probability which is given to that ball box is selected, urn is selected? The probability of urn U1 is 1.3. Okay, probability of U2, urn 2 is selected is also 1.3, and probability of U3, urn 3 selected is also 1.3, because there are 3 boxes and they each has probability of 1.3, 1.3, 1.3. This is probability of selecting urn. Now, what is the probability of likelihood probabilities? Which are those likelihood probabilities? Now, A upon likelihood probabilities. Now, the likelihood probability. This is known as likelihood. Now, the likelihood probability, these are the prior probabilities, 3. Now, the likelihood probabilities are probability of A upon U1. that red ball selected is from urn 1. What is urn 1? 6 red balls. It is 6 upon 10. Total 10 balls are there. Yeah. And the probability of A upon U2, from second it is 4 red balls. It is 4 upon 10. And the probability of A U3. This is the likelihood property that from urn 3 the event A is selected. So this is how much? This is 5 by 10. 5 by 10 because 5 red balls are there in the third urn. So these are the 3 likelihood properties. Now multiplication of these with respect to these will give us the total probability in the denominator. Now the probability. Now let me find out the probability final solution we are finding out. Very important point is here. Now the probability by base term, the probability of posterior probability is known as posteriori or posterior probability, posterior probability of selecting or drawing a ball from the urn 1, right? From the first urn, selecting urn first or selecting first urn and selecting and drawing a red ball and drawing a red ball from it. What is that probability? That is known as, let me just put here the formula. That is probability of E1 oblique, or let me take this is U1, I'm sorry. This is U1 here. Urn 1. Event is A we have taken. U1 upon this is probability of U1 into probability of A oblique U1 divided by total these sum. What is that? Probability of U1 into probability of A upon U1 plus probability of U2 into probability of A oblique U2 plus probability of U3 into probability of A upon U3. This is the formula by base theorem. Now this is from R number 1, right? What is the probability here? 1.3 into probability of A by U1. This is likelihood probability, which was 6 upon 10 into 6 upon 10. In the denominator, what do we have? 1.3 into this 6 upon 10. This is first urn plus second urn is 1.3. Selecting this PUT is okay, 1.3. Probability of A by U3, which is how many balls are there in the second? 4 upon 10 plus 1.3 into 5 upon 10. Try to understand. This is sum of all the likelihood probabilities. These are the likelihood probabilities. Okay, and this is 1.3 prior probability, multiplication of prior probability and likelihood probability, sum of these two. So this can give us 330, 3 into 10, 30 in the denominator, 6 upon 30 divided by 6 plus 4, 10, 10 plus 5, 15. Okay, so 6 upon 15 answer is coming. Let me write here. Only what is the answer? 6 upon 30 divided by 15 upon 30, because 6 plus 4, 10 plus 5, 15, 15 upon 30. So 30 cancel out. This is 6 upon 15. Final answer is the probability of selecting a red ball from the urn first is this. This is 3 2 ja 2 upon 3 5 ja 3 2 upon 5. This answer here. So probability of selecting a red ball from urn first, or this will be selected from urn 1, or first urn is selected and red ball is drawn from it. The probability of that is this 2 upon 5. So this is known as posterior probability based theorem. So by base theorem, we have applied this completely the base theorem here. Okay, so this is how base theorem is applied. So first urn probability of U1 by A. This is known as posterior probability by by base theorem. Base theorem we applied. this probability be probability of u1 into probability of a upon u1 be put in the numerator divided by the sum of all the three Rn's probabilities and their multiplication. Selecting the Rn is prior probability, okay, and selecting a red ball from the Rn is likelihood probability, because they are going to happen, they are likely to happen. So prior probability plus likelihood probability, multiplication of them will give us the posterior probability, which is Bayes theorem. Bayes theorem is based on these two kinds of probabilities, prior probabilities and likelihood probabilities. Okay, so this is how the Bayes theorem is applied here completely. The last question, question number 6, is completed. This is how these questions are there. Next questions I'll take, some more questions are to be taken here. So I'll continue this lecture series in the lecture number 47 next. This is 46 completed. But in 46, what we discuss about that what is Bayes theorem, what is the importance of this, because now in the world of uncertainty, mostly in the management field, when the managers have to take the decisions from different available what you call possibilities or uncertain samples are given to us. Now from those samples we have to select our required decision, and then decision is taken. But still it is uncertainty. Uncertainty is more here in case of Bayes theorem. But Bayes theorem has given us some solution of this. So we can find a solution or decision we can take with the help of this Bayes theorem, applying the Bayes theorem, and we can find a proper solution of those uncertain conditions given to us. Okay, so this is how decision making has made easier or has become easy with the help of Bayes theorem. Bayes decision theory is based on this question. Okay, so all these questions we have completed. Now these 6 questions, sometimes we are just calculating only the likelihood probability. We have to find out that what is the probability that the, for example, in the 5th question, we just selected that what is the defective balls, non-defective balls. Which was there? This one, 4th question, I think, defective balls. Yeah, one contains box, one contains 3 defective balls, 7 non-defective balls. Defective balls and non-defective balls, but the probability of them only. So those likelihood probabilities only we calculated. Okay, and then posterior probability is the 6th, the C part of this 4th question we did, and there we applied the Bayes theorem. Okay, so Bayes theorem is applied wherever it is required, but just to take the decision in uncertain conditions or uncertain situations. That is how Bayes theorem is applied. So Bayes theorem is likely, I mean, this is simply clarified, but still I have to take some more problems, because some students have requested me take some more problems so that they can understand the topic here. Okay, so this topic is undoubtedly is very not difficult one, but I think the systematic thing. We have to just understand that what is Bayes theorem, why it is applied here. Okay, so Bayes theorem is applied just to solve the problems which are based on some samples given to us, and those sample problems. Posterior, this is one posterior probability. Why? Because this is based on prior information or prior probability and likelihood probabilities. Then it gives us posterior probabilities. Now this posterior probability can become prior probability for next problems or next sample development. Sample development means decision taking process. For next decision taking based on this probability, whatever we have calculated here, and then this will become a prior probability, right? So prior probability, likelihood probability will give us the posterior probability. Posterior probability is calculated with the help of Bayes theorem. Okay, so conditional probability is just a part of this, because most of these what you call likelihood probability are conditional probabilities. So conditional probabilities plus prior probability, they are giving us the posterior probabilities. Okay, then see you in the next lecture series, which is again very important, because I'm going to take some more difficult level questions or some simpler one also, so that this topic is further clarified. That because Bayes theorem is very important for some of the most examinations, like technical courses mostly they are given. Even in 12th standard it is given to us. Competitive examinations also they are giving these questions, and mostly technical, BSc, MSc, they are in science courses mostly, or the science students are having Bayes theorem. They have to face this. Statistics is also, in statistics, subject statistics is being studied by some of the students, and they are facing this probability. Okay, so what is conditional probability, what is the Bayes theorem, all this probability distribution, okay, then probability distribution we talk about also. Okay, so then normal distribution, binomial distribution. What is binomial distribution? Binomial probability distribution. That is also very important one. Okay, that we will discuss in the next one of the next lecture series. But I still have to continue this topic, which is what you call binomial, this Bayes theorem. Okay, see you then in the next lecture series, which is in continuation of this. Okay, then bye.